Hello everyone and welcome back to another video, and today I have some quite exciting news to share because the first 3D printed F-111 has been assembled and is technically flight ready. It's not what you see in front of you right now. The plane is not at my flat anymore, it is now out where the airfield is. So instead have this mini version of what is actually the next generation design, as well with the full-size parts of that next generation design which are already printed. But first let's go into what I actually wanna really do in this video, because this could end up being a bit complex. So first of all, I wanna talk about the landing gear of the plane, because it is it's a part of the design that I really like, that really went well, that I haven't really talked about in detail yet, and I consider it quite important. Actually so important that I got some extra help with this project from PCBWay, who helped me manufacturing the parts for this. PCBWay is also today's sponsor for the video, so more on that later. Then I want to go into assembling the first prototype, which is SN2. Now to briefly explain the serial number naming scheme. SN0 was the first prototype, that was just the external shape of the plane, no internals, never supposed to fly. SN1 was the first prototype attempt, but I ended up abandoning it because there were some problems with the internal design, and I ended up changing it so much that reusing the parts wasn't really possible. And then I made SN2. And SN2 is the first fully, as of me filming this right now, fully assembled, fully functional in theory prototype of the plane, and that's the one that we did all the testing with. And what you see in front of you right now is this is part of SN3, which is already completely done in terms of the parts are being printed. And then right here is a mini version, a exact replica of SN3 at 50% scale. And yeah, this actually inspired another idea of maybe I'm gonna make a mini version of this, because I've had this idea for a while, and then I made this just to show the plane off, because it's easier than, you know, taking the full-size plane and trying to shove it into the camera. Yeah, and then once I had printed it, I was like, oh, maybe, you know, like they do make 30mm EDFs, and that battery hatch does fit a 3S battery. So I was like, hey, maybe we could like make a mini version of this. And I sort of had this idea, and then literally 2 days later, René Rosenträger, who is another YouTuber who does a lot of 3D printed RC plane projects, who also served as a great inspiration for my own designs, did exactly that. He made a 50%, or I'm not entirely sure if it's 50% scale, but it's like 30mm EDF scale, the same that would go in here, version of his own 3D printed plane, and made it work. So now I'm going like, yeah, this is very possible. So that might be a sort of split-off, spin-off project. That might be a thing, because it should be relatively easy to do. But yeah, let's just talk about the main thing. For now, this mini is just for show. So, the landing gear. The landing gear for this plane is very, very important. It was actually one of the very first design considerations and design goals for this entire project, before I was even really sure that the rest of the project would even work, because for most RC airfields, at least for my RC airfield where I fly, you have the situation of the runway is a grass field, there's no paved surface, it's literally just a grass surface, and yeah, we do mow it, and we actually even have a like, what do you call it? I don't know the word in English, but like the big vehicle that makes the ground flat, you know, that. So we use that every year, and we make the runway flat and stuff. But it is still out, you know, not in the city. It's very much on the countryside, close to a forest, which means we have wild animals, specifically wild boars, that walk onto the runway and dig it up and do stuff to it. And yeah, like, just the runway is not in the best condition most of times, which is something that we've just sort of come accustomed to. But there's a bit of a problem. Most RC planes, which have retractable landing gears like this project, their retractable landing gears are very simple. You have a retract servo, which is the same for my design, and then you have, most of the times, literally just like a metal rod with a wheel on the end, and that's the entire gear assembly. And yeah, that's fine, that's simple and fairly light, but the one problem is, if you have a landing on a runway like that, or just a hard landing in general, or a hard landing plus a runway like that, and you run into like a little bit of uneven ground, what tends to happen very, very frequently is that you rip the landing gear out of the plane. Or otherwise, like, there's different things that could happen. The landing gear itself could snap, you could rip the entire servo out of the plane, you could rip the wing off of the plane, which has happened. And it's just really bad. Even if you don't break anything, the loads that you put on the plane are just very, very high. And while lightweight PLA is kind of bendy, like you can see here, it is still PLA, and PLA is, while it is pretty good at static load, it is not very good at dynamic load. Like, when you overstress it, it is going to snap immediately. So I want to avoid putting large dynamic loads into the airframe, because then, well, it lasts longer, and I can also make it lighter. So, conclusion of all of that is I wanted a landing gear with a suspension. Now, there are pretty easy ways to get suspension on your landing gear, and I've done basically that. Now, my design is a bit atypical, because of it needed to be a certain shape to fit into the plane. If you look at the bottom right here, specifically the two aft gears, you see how that goes into where the EDF sits. Like, this is an open hole into the air duct. This is not a separate chamber, because the fuselage is just that thin. And in order to not obstruct the airflow for the fans, the landing gear needed to be flat. So it is flat, but also rather long, and therefore has this sort of long stick shape, which is not what you typically see. Usually you see a landing gear that's a bit shorter, but has a bit of an angle to it, so that the gear cannot be loaded backwards, which could theoretically happen here. If you shove the plane backwards, the gear could be loaded into the opposite direction. Which is not really an issue, the gear can take that. There was just an issue with SN2, where one of the hookup points was a little bit different because it was a slightly older design, and that one didn't have these extra tabs here that hold the gear in, so when it was loaded backwards it would like lever itself out, and that's obviously not good. So yeah, but the main idea for the gear is just this. Instead of one static thing, you have two parts which have a joint, and then those two parts are being held together by rubber bands or a metal spring. In my case, I used rubber bands. Not specifically rubber bands, I'm actually using O-rings for water tubing. Mostly just because I walked into the hardware store next door and just picked up some O-rings, because, you know, O-rings are essentially rubber bands, and they are designed to be quite durable, so they're a great choice for rubber bands that you can use for a suspension. So yeah, that is how the entire thing works. You just have two parts, and then when you put load on the gear, like, it is assumed that you are going forwards, because if you just put load from right above, then of course nothing's gonna happen. But like, if you're moving slightly, then it's gonna bend the lower part a little bit, and then that way the bands have load placed on them, and then the entire thing can deflect to a side and take the load that way. And that way you can get rid of a lot of just big smacks on hard landings, also just an uneven surface. One thing that worked quite well is that if you have the plane going at a high speed over a rough surface, the landing gear just kind of takes it and the plane doesn't start hopping around from side to side, which is very good because this plane probably needs to be quite fast to take off, because it is an F-111, it is a supersonic airframe, so it needs to go rather fast. So yeah, so that's the main design idea for the landing gear, and then comes the part of manufacturing, because that is a custom design, that is not something you can buy. I designed this myself, so I'm gonna have to make it or have someone make it for myself. And well, I can't really do it the same way as I do all the other parts, because like I already said, lightweight PLA is rather bendy and it's still PLA, so static loads okay, but dynamic loads bad, and the landing gear will mostly see dynamic loads. And that brings us to the point of, well, I can't use PLA, but I exclusively use PLA for 3D printing. I don't use any other filament than that, and I don't really plan to use any other filament than that. So I was gonna have to look at, okay, now I need to get a new material, I need to make the printer capable of printing it, and then I need to figure out the settings and everything, and then that would just cost a bunch and it would take a bunch of time. And I didn't want to have to deal with that, especially when I looked at what material I was gonna go with, because I kinda wanted to use nylon, because nylon is very, very durable, especially for applications outside. Like if you think about it, the grass runway, well, it's gonna be some sort of wet and it's gonna have some debris on it, like sand, and the day we did the test flight, it was just after raining, so the ground had a little bit of mud on it as well. So the landing gear really, it got quite dirty, and you want to take a material that's like outside proof, and that's nylon. Problem being, nylon is one of the worst materials to 3D print yourself. It is extremely hard to get right, and basically none of my 3D printers are capable of printing it because it is an extremely high temperature material, and it warps really easily, and you need to dry it really well because it is extremely hygroscopic, and just generally nylon is really, really hard to work with. So I think I have a better solution, and that is where PCBWay comes in. PCBWay is this video's sponsor, and they have been helping me with this project by manufacturing those landing gear parts for me. Specifically, like I wanted, out of nylon, and even, because they have that offering, glass fiber reinforced nylon. And that is not just a simple, oh, we can do other materials for you part. PCBWay has a very, very special 3D printing procedure that they offer, because they do SLS 3D printing, which is very, very different from FDM 3D printing, which is what I do. In FDM 3D printing, you have a hot end that melts a filament into liquid plastic essentially, and then deposits it layer by layer. In SLS 3D printing, which stands for selective laser sintering, it is very different. There is no hot end, there just is a tub that is filled with material powder, and that's the material that your part is made of. So in my case, some glass fiber and nylon powder. And then instead of a hot end, you have a high power laser that is being focused on a specific point on that powder. And the laser gets so hot that it fuses the material together. If you've ever heard of a process that kind of sounds like this, it's because this is actually the same process that Boeing uses to manufacture the engine pylons for their Boeing 787 Dreamliner. Just that they do it out of titanium, and not completely, they make the raw material out of that and then machine it back down. But it is still the same idea. And SLS 3D printing doesn't really exist on the consumer market. There is one little startup that is trying to bring it to the consumer market, but that doesn't exist yet, and it is also still many, many times more expensive than an FDM 3D printer, so realistically it doesn't exist on the consumer market and will not be for quite some time. So it is very helpful to get these kinds of parts from PCBWay, because SLS 3D printed parts are just so good. Like, the quality it's not quite on par with resin 3D printers, but it is a lot closer to resin 3D printers than to FDM 3D printers. You get some very, very good part quality, and not to mention the layer adhesion is so much better because that laser just really fuses material together. It's not just being held together by the material cooling and kind of attaching to the lower layer like on FDM 3D printers. That is the main problem with FDM, is that your layer adhesion is usually the weak spot. So yeah, I'm really thankful to have gotten these parts from PCBWay, because those parts, like, they're just great. I think that these parts are going to survive many prototypes. Like, in all honesty, I don't think SN2 is going to live for that long, which is why we've been doing ground testing first and haven't really flown it yet. Because I have a feeling once it takes off, it's probably not going to come down in one piece, which is part of the reason why SN3 is already here, ready to be assembled, and SN4 is already in active development. So it's good to know that that landing gear is sturdy enough to, you know, just survive the prototype, because even in a very bad crash, I don't think that that landing gear is going to get damaged. The parts are very strong and durable. So yeah, the fuselage are probably gonna have to be scrapped after a crash, but all the parts, including the landing gear, is gonna be able to be reused, which is good because I can just put it into SN3 and then have another plane ready. And with all that said, big thank you to PCBWay for helping me with this project and sponsoring this video and my channel for so long. They are very helpful in making these projects happen and in enabling me to do more expensive projects, and it is just really great to have a sponsor like PCBWay. And if any of that sounded interesting to you, here's a little bit more of an overview about what specifically they can offer. If you are working on a project of your own that requires parts that would be hard to make yourself, or just generally parts at a much higher quality standard, you can go to PCBWay's website and order anything from PCB prototypes, assemblies, CNC parts, 3D printed parts, as well as stencils or even flexible circuit boards. The ordering process is simple. You just upload your files, tell them some stuff that you need, and you'll quickly receive a quote, which once accepted, will mean that your part can get shipped out within as fast as 24 hours. And if you have any questions or require further help, they even have a live chat service that stands ready for you. So if you need some custom-made project parts, don't delay, go to PCBWay today. So, with all the design talk done, now it is time to talk about what actually happened with SN2. About a week ago, I brought SN2 and all the remaining parts to the workshop, and we put SN2 together. It was interesting. There are already some design changes from SN2 to SN3, and yeah, it was a bit of a process to put SN2 together. But in the end it all worked out, and we had what was a perfectly capable 3D printed F-111 that was ready to scream across the runway to see just how would it do. And that's pretty much exactly what we did. We put the plane on the runway and charged up 2 of the 6S 6000 batteries and emptied them while running the plane over the runway a bit. And, well, good parts first. The landing gear design worked perfectly well. It did exactly what we wanted it to. It took shocks, it dampened out the uneven terrain, it did everything well. Like, that worked perfectly. The swing wing also worked perfectly. The nose wheel steering was strong enough to turn the plane without relying on the rudder, and just generally the plane took the abuse. Nothing broke, except for one little thing that we'll get into, but the plane itself was fine. Everything worked out, and yeah, that was good. Now let's get into what maybe didn't work that well. Well, first of all, I need to put more rubber bands on the landing gear. Now, in itself, it worked fine, and the landing gear is designed to take up to 4 rubber bands per landing gear. I only had 2 of them on there, and also the slightly larger ones. I had 15mm bands on. I also have 10mm bands, which are a bit more stiff. And I'm gonna have to put the more stiff ones on, or just more of them, because the landing gear was a bit too soft. Like, if you have a large enough oscillation, the landing gear would just kind of bend in really like strongly, and then you would have a problem where your wingtip might be touching the ground. We also had the problem of the day where we did the testing. It was quite windy, and the wind was actually strong enough to bend the plane down to one side because it compressed the landing gear on that side. That's how strong the wind was. So yeah, more rubber bands on the landing gear to just get it a little bit more stiffer, and that's an easy fix, so we're just gonna do that. Onto what's a little bit harder of a fix but still easy. The nose wheel steering servo. You can see where it goes right here. That's where a little servo sits in, and that actuates the the steering for the nose wheel. That servo broke. It wasn't a big surprise. It was one of the extremely cheap 9-gram servos, which are just completely plastic, and well, after running over the runway and, you know, having bumpy terrain and high speeds and turning at those high speeds on that bumpy terrain, one of the plastic gears in that cheap servo just gave out and the servo broke. Which, kind of unfortunate, but not really too much of a bummer. My dad has a big box of servos harvested from, you know, unfortunate planes that ended up crashing. And we just took a nice one that has like a metal gearbox instead of a plastic one, and that's just gonna go into the plane, and that servo is gonna probably take the abuse much better than the cheap plastic one. Then, one issue that's a bit more harder to fix. Specifically, it might just not be fixed for SN2, probably also not for SN3, but SN4 is probably going to fix that. And that is that the plane is actually a bit too nose heavy, which was a surprise, because if you look at this, now we tested all of this with the wings folded out, and that's how the plane is balanced with the center of gravity. And the center of gravity should be somewhere here, between the seam and that rotating point. Somewhere here is where the center of gravity should be, if you go by the rule of thumb of like, here you want it at the first third of your wing. And it's also based off some aerodynamics testing we did with another 50% scale version of the model. If you look back at some of the older 3D printing videos I did, you are gonna see that thing being made. It's like very similar to this 50% scale, but entirely red and out of much, much larger individual parts. And we used that one to just sort of figure out like, where is the natural aerodynamic, like where does it want to have its CG to like glide well. And we figured out that, you know, the base model by itself is tail heavy. So I think we ended up taping a 20-cent piece to the nose, and then it flew like pretty evenly, pretty nice. So that was good. Like the airframe by itself is pretty well balanced if it only needs a little bit of nose weight. But once the parts are in, you have to think about that, well, really the heaviest parts that go into the plane are the engines, which are the 2 EDF fans that sit about here. And both of these are 130 grams each. But then over here goes the battery. And the battery is 850 grams. And you can see how it sits in front of the center of gravity. Now it's a lot closer to the center of gravity than the EDFs, but that didn't quite help. The center of gravity is about 2 centimeters too far forward. It is, instead of being here, it is about here. So on this 50% scale model, like about 1 centimeter. So it's slightly in front of this seam right here. Which is of course too nose heavy, because like look how much of the wing is behind the center of gravity. The main problem with this is it's not really fixable, because the battery is already as far back as it goes. And really the only thing we could do is just tape weight to the back, which we might try, but then the plane is heavier. SN2 is the first prototype, and it has a lot of not really optimal things, like a bunch of things that we ended up improvising and changing a bit, and also the part where SN2 is 2 individual halves of plane that then have to be glued together, whereas SN3 is now a uniform design. That added extra weight, because 3D printed parts, they have infill, specifically 5% infill, and the outer walls, well, those are essentially 100% infill, so the outer walls are 20 times more dense and therefore 20 times heavier than the inside of a part. And if you have a split down the middle of your plane, well, that's a lot of extra exposed outer surface that's going to contribute to your weight. So yeah, SN2 is quite heavy compared to the intended design. Now it is still within range. The design was a range of 2 to 2.5 kilograms, and SN2 is somewhere between 2.2 2.5, so still within the range, but of course I would have liked it to be a bit more to the 2 kilogram side. Well, SN3 might get there. SN2 is not with the large 6000 milliamp battery. We do have a 5000 milliamp battery, which is probably the backup that we're just going with, because that is 700 grams instead of 850. So that itself would just fix the center of gravity probably, but well, the 5000 one, it's gonna last even less, because with the current draw set in the datasheet for the fans, the fully charged 6000 battery, which is a massive battery, like 850 gram battery, at full throttle, that's going to last exactly 3 minutes before it's completely empty. So that's not that great, and the 5000 one is gonna be even shorter. Now, we don't fly full throttle, but the first test flights are gonna have a lot of takeoff and landing testing, and also probably just taxiing on the ground, and we only have one 5000 battery, and they take ages to charge, so it's probably quite unoptimal to use the 5000, but that might just be what we have to do, and then fix the center of gravity with the newer designs. So yeah. And then, is there anything else to say? Not really. Not really. So that's what we took away from testing SN2. So 2 easy things to fix. Just the nose wheel steering servo needs to be replaced, and the landing gear needs to be a bit more stiff. And then the harder issue with, it is actually quite nose heavy. Like pretty nose heavy. I'm not sure if just pulling up more is going to fix that, because it is very nose heavy. So yeah, that is not so great, but yeah, we might just do that workaround with the smaller, lighter battery. Now let's get into the last part, the future developments in design. Let's first talk about what's different with SN3, because it is quite similar to SN2. There are only really 3 main differences. One I've already mentioned. SN2 is a uniform design. It does not have a split down the middle. You just have one fuselage that is, stacked parts. You don't have individual halves that need to be put together in the end. That is the first change for SN3, which is going to make just the assembly easier and also lighter, because we are saving a lot of extra exposed outer surface. Now, with this uniform design, it obviously becomes hard to access all the electronics, like the electronic speed controllers, the swing wing servo, the servo extensions for everything back here. So instead of pulling the plane apart into halves, SN3 has these 2 parts, which house the landing gear, be removable. So you can see the seams down here. So this entire thing and the entire thing, those are removable. So you get access to everything, and then once it's done, you put the landing gear on, and then then it's sealed off. Then you better know what to do. But yeah, it's better than having individual halves and then mash them together, because it was quite difficult, because the entire plane needs to be put together at once, and there's quite a lot of wires in between that like to stick out and block things. So yeah, that's one of the major design changes for SN3. And then the other 2 are aerodynamics changes. So the ailerons have been enlarged. They are 20 millimeters or 2 centimeters longer in the back. If you look here specifically, you see how the aileron goes all the way to the back of this little fuselage extension. On SN2, it doesn't quite. There's like a little bit of distance left. So on this 50% scale, again, like a centimeter got added to the back of the ailerons here. And then the wings have also been changed. Now these have undergone a bit of a larger design change. They have also been extended by 20 millimeters to just go flush with the ailerons. But as you can see, if you look at footage of SN2, the wing tip is quite different. So instead of having this very rounded shape, it has a much more realistic shape. It's still a bit rounded, but very minor rounding. This just makes the wing, well, it adds surface area to the wing, which means more lift, which means we can fly slower. And also at the same time, when the wing is extended, this means that even though it has this very slight wing sweep. It's a very slight sweep, like it's not that much. This makes it essentially a box wing, and these are quite common on trainer aircraft, like something like a Funman or just any Cessna derivative or Cub. They tend to have these rectangular wingtips because rectangular wingtips are less likely to have an asymmetric stall. So when you go too slow and you stall the wing, what happens with these rectangular wingtips is that usually the plane just starts sinking. And that's all that happens. With a swept wing, like a strongly swept wing, like the very thin tips that SN2 has, or just a very aggressively swept wing, like when the wings are folded back, what tends to happen when you stall is you get a very nasty asymmetric stall, and the plane is going to drop a wing and flip on its back. And that better happen high up, because if you're low to the ground, that's it. You can't recover from that. So this way, when the wings are folded out, which is what the first couple test flights are not gonna sweep the wings back, we just want to make sure that it flies. That's going to make the first flights a little bit, easier, and also it's just more realistic to the real-world model, because the real-world F-111 does have these kind of boxy wingtips, not the super smooth ones that SN2 has. And to accommodate the larger wing and the other wingtips, the entire wing has also been slightly thickened, because this is just lofted in Fusion 360, so it is very slightly thicker. Doesn't matter that much though, to be honest. But yeah, those are the main design changes for SN3. So overall, the plane is going to have a little bit more lift, it's going to have a little bit more control authority with the larger elevons, and it's going to be a little bit lighter because we are saving all the extra 20 times heavier outer surface in the middle, which is 2 outer surfaces, mind you, because there were 2 halves. So really it's 40 times heavier. So yeah, that's the design changes for SN3. And like I said, all the parts for SN3 are already done. Like, this is just the front section, but everything else is already printed, and like I only need to get the electronics and then glue it together, and then we have another plane. And yeah, this is what SN3 is going to be. SN3 basically exists to just replace SN2, because as I said, I don't really expect SN2 to hang around for that long. It's probably going to crash, because it is the very first time I take off with that design, and I have no idea how it's gonna behave, and there might be some major design flaw that we just can't find until we actually try to fly it, so there's a very high chance something goes wrong and it crashes. Especially with that very nose-heavy center of gravity. It might just, not want to climb, and then it goes down. And with that pointy nose, it's gonna bury itself. So, yeah. And past SN3. Now SN3 was already done, printed, before we did the tests on SN2. So SN3 was kind of just like a, things that I thought would be better that I didn't actually do any testing on whether they would be better. And SN4 is the first design that is actually based on some of the things that we've seen. Now SN4 isn't done yet, it is still being designed, because it is going to be a larger redesign. Because one of the things that we're going to do is SN4 is going to have larger air intakes. Now that is going to mean that we are going to sadly have to remove this little scale feature right here, this intake cone, because, without that you have a decent amount of extra airflow into the inlet, and also we're going to add some little holes into the bottom of the fuselage to just have more air into the EDFs, because one thing we noticed is that when the landing gear was folded out, we got about 100 grams more thrust than when it was folded in, because this was used as an extra air intake. And 100 grams of thrust difference, that's quite a lot. Like that is enough to bring us from below a 1-to-1 thrust to weight to above a 1-to-1 thrust to weight. So I want to get that benefit of giving the EDFs more air to work with, and therefore we're going to be increasing the amount of airflow that goes into the EDFs on SN4. Another thing is that I'm gonna be experimenting with increasing the angle between these two aft landing gears. Like you can see, they are slightly angled outwards so that you have this, the tricycle gear arrangement. And while the stiffer landing gear is probably going to fix that, I could probably help it by just increasing the angle a bit more, because the landing gear, it is still quite close together. So when you have a day like we did when we tested, where you have strong winds and it blows the plane to one side, you can still end up having a wingtip strike, and that would be very bad when you're going fast. So I'm going to experiment with increasing the angle between the two landing gears to have a little bit just better, being more resistant to being blown over. And then we're going to have the most major redesign of SN4, which is that basically the entire top surface here, this entire part of the fuselage, is going to be redesigned. And this is something I really didn't want to do because, first of all, I really like how this looks already. And second of all, I basically have to redesign the entire fuselage for this, minus maybe the nose, which is going to take a lot of time. But what we've come to realize is that the plane would probably benefit quite a lot from having a proper aerofoil. Now, if you look at the wing shape right here, you can see it from this imprint it doesn't really have an aerofoil shape. It is a symmetric aerofoil, and it's not any specific NACA profile, it is just what fit inside of the fuselage, because as you can see, this is very thin. We have, there's just nothing else here, and then below that we have all the air ducting, so the wings just really can't be thicker than this, and the wings are fairly thin. Now, the wings are strong enough, they're not going to break, but thin wings like this do not produce a lot of lift. And yeah, that's the main issue. I don't want to end up having a plane that you have to fly super, super fast. I want to have the plane be capable of also flying slower. And with these super thin wings, especially these symmetric wings, because this is not a 3D acrobatics plane, it doesn't need a symmetric wing. It's just what, happened to fit, and having a symmetric wing would be thicker than having an asymmetric wing. Because the leading edge has to fit with this leading edge, and then the trailing edge has to, fit inside here. So, yeah. I've come to the realization that it would probably be good to add a proper NACA profile, something like a 2410 or a 2412 or something like that to the plane. And that is only possible if I make this section significantly thicker. So you see how it kinda comes down after here, and then gets very, very low here until it meets the air ducting. I'm gonna increase this. I'm gonna leave this thicker, and then have more room to work with to put a thicker wing in there with a proper aerofoil. And because this entire thing is like one solid surface, all of this has to be redesigned. Even this edge over here has to be made thicker to accommodate the wing in it, because again, still these need to meet up, these two leading edges. So that is the main part why SN4 is a bit of a larger redesign, because yeah, I'm gonna try to get a proper wing profile into this. And then there's also some smaller considerations, like making the battery hatch a bit bigger, because we had some issues getting the battery in there, like barely fit, and stuff like that. And also just moving the EDFs back a little bit to counteract the center of gravity. Like, the EDFs, we can theoretically move them all the way back here. And then, they're not heavier, but now they're just really, really far away from the center of gravity, and as opposed to the battery. So now, there's going to be a moment equilibrium. So, yeah, that's like one thing that I'm probably gonna do to fix the center of gravity. And yeah, one last thing. Yeah, SN4 is also going to have some changes to the rudder, like just the movable part of the rudder, which is this back here, is gonna be like made larger. It's gonna be like this, probably, just to have a rudder that's more effective. And we've had a little bit of an issue with the elevon control being a bit flimsy, like it would just wiggle around a lot, which is gonna be a problem once you go faster, because then you can have the thing just shake itself apart, which we obviously don't want. So there's gonna be, well, the main part is just getting higher quality servos and better hookups, but yeah, there's going to be some changes to make these more rigid when attaching. And one thing I also thought about is, if the surface is going to be thicker, then I'm probably gonna be able to move the carbon rod that attaches the elevons just over this thrust canal. Because right now, if I would have a carbon rod that goes all the way to the middle, it would be inside of the air ducting, which I don't want to. But if I make this top surface a bit thicker, I might be able to just fit a carbon rod above the air duct, and then have also just a more rigid hookup that way. So, yeah. that's SN4. Well, first we're gonna fly SN2. Like, we're gonna do more tests with SN2, we're gonna try to fly it. And then once we're done using SN2, we're gonna build SN3 and also do a bunch of testing with that one. And then by that time, hopefully, SN4 will be done designing and I can build one, and then hopefully SN4 is going to be, you know, the final version of this. And then maybe I can look into things like making the mini fly. Because I really like this concept of a mini. Like, it is very, very light. Like, this is maybe 250 grams. And yeah, like, put a 3S battery in this, like 2 little 30mm EDFs. Having the swing wing work would even be possible. Like, you use some high quality, like one of the small high quality servos instead of a big 25 kilogram one. The small one doesn't need a landing gear, the small one doesn't need a rudder, you just need 2 servos for the elevons, which you can like stick in the middle somewhere here and then have the actuator like that. You know, it would be kind of fun, because this mini is, like, it would be a lot cheaper to build, a lot lighter and a lot easier to print, and I think this would be like maybe a little bit more interesting for someone who doesn't want to build the big one. I mean, the big one is still not that expensive to build. That's like the entire point of 3D printed planes, but still, the big one is, it's an EDF jet. It's a dual EDF jet with a swing wing. This is not an easy plane to fly, and crashing one of the small ones is probably less of a problem than crashing one of the big ones, because the small ones are so light, as long as you land in maybe like some tall weeds, it might not even break from a crash. So, yeah. With that said, though, the video is now very, very long, and I've talked a lot about 3D printed planes. So, I hope all of this was interesting, and I hope that soon I can give you some more info, maybe some footage of a test flight or test crash. And yeah, I hope you're excited as I am. I know this is not a seaplane channel. Well, it is a seaplane channel now, but it is primarily still an overclocking and modding channel. There's gonna be more content about that. I just received some... actually, I can show them. You know what? I'm just gonna show them. I just got these recently, which are prototypes for a DIY e-power made by ASIC, who's another overclocking YouTuber. Check him out. Definitely, he deserves a lot more subscribers than he actually has right now. So yeah, there's gonna be a video about these, because these are really, really cool. And yeah, there's some more overclocking stuff planned, so don't be afraid that this is all gonna be seaplanes now. Because the overclocking content does get a lot more views, I've noticed. Anyway. Yeah, huge thanks again to PCBWay for helping me with this project. The landing gear parts they made were just really, really good. Like, really, if you need parts like that, some small parts that are not worth getting a 3D printer upgrade or learning a new material for, go get them from PCBWay. Those are just really good. Like, SLS 3D printed parts are just really, really, really cool. It's not even the first time I had that idea. Like, my dad is also building a plane, not a 3D printed one, but he's also building one, and he also had the same idea. He got an SLS 3D printed landing gear for that one as well. So, and they already load tested it as well, and apparently they broke the tester before the landing gear did. So, yeah, anyway, huge thanks to PCBWay for helping me out with this, and with that, thank you all for watching as well, and until next time, goodbye.